Elysée. So everyone, welcome to the session of Fold and Cut done by Elysée, Wilson-Egolf. And Elysée is, I'm proud to say, a friend and colleague at BATMath, which is Bay Area Teachers and Mathematicians. It is a local network of MTC here in the Bay Area. I'm in San Jose. Elysée teaches math, does math, and runs BATMath. She is the director. Important credentials include being lost in time and space and enjoying cloud photography. Elysée will start her PhD in math at UC Davis this fall after a few years in the classroom teaching everything from counting to college level mathematics. And without further ado, I hand the floor to Elysée.
Thank you.
Have a good session.
Thanks. Okay, so we're going to get started today actually with a magic trick. And the first question of today is going to be about how to duplicate this magic trick. So please pay careful attention. Okay, I'm going to start with a normal piece of paper and a pair of scissors. And what I'm going to do is I'm going to fold this in such a way so that with one cut, I can make something unusual. So that you can see, this is what it looks like before I'm going to make my cut. So what's important about this cut is that it is straight, it is complete, meaning it goes all the way through and makes two pieces, and there's only one of them. Then, when I unfold it, I get a star shape. Okay. So let me also show you what's left over. The piece of paper has not been mangled, but instead we get, well, it's been mangled a little bit. Instead we get nothing but the star left over. So this is the question. How is it that you can make one straight cut and get a star and the area around a star and nothing else? Are there any questions now before we get started and go into table groups? Okay. So there's 7 of us. Oh, well, you'll just need scissors and paper. That's it. Yes, you should have supplies. Does not have to be square. Nope. We actually have a few more people, so why don't I show you with a rectangular piece of paper? So this is bog standard. I actually cannot see you at all. All I can see is your chat messages. When we go to the groups, though, if you turn your cameras on, you're going to be able to show each other everything that you're doing, just like I am right now. Okay, so here is a rectangular, sorry for the noise. Here's a rectangular piece of paper, and I'm going to fold it, and fold it, and fold it, and one more time. Here's the shape. And and here is another star. And as you can see, there's nothing left. Okay. I am not intentionally hiding the folding from the camera. But I do want to just pose the problem so that it's less about reverse engineering and more about engineering. So give it a shot, and eventually we'll do it in slow motion under my document camera here. But right now, it's a magic trick, right? So if I show you all of the smoke and mirrors, then you'll lose some of the charm. Okay. So if you're ready, let's go, and I'm going to stop presenting. Please form a maximum of 2 groups. I think, yeah, 2 groups, one of 4 and one of 5, perhaps. And let's give this problem a try. Okay, thank you very much.
So we're trying to make stars?
Yes.
Oh, yeah.
Catherine?
Yes.
I'm not hearing you. I hear you. I see you. Can you hear me? I can't hear Catherine.
Is it off? Let me turn my mic on and then off and then I'll turn it back on.
Check, make sure your mic is on, or maybe I have to refresh.
Hi, I'm just joining.
Hi.
So I made this.
Okay, so yours is 6-pointed?
I don't know if it's
Yes.
fold it in half. Fold it in half. And fold it like diagonal.
But it happened.
Oh!
Now that's with a rectangle.
Yeah.
Rectangle.
So show me again. Fold it in half.
I don't know what I did. I just sort of folded it a bunch of times.
So you folded it in half.
Yeah.
And then you fold it in half again.
No, I did not fold it in half again. I folded in 1, 2, 3. Folded it 4 times.
Well, Ingrid was showing in half and in half.
Yeah, half, then half.
Okay.
Then,
Oh, yeah.
and then I folded it.
That one doesn't go all the way up. It's not a full diagonal.
Well, what if I put it back in for you? Look, I did it this way. See that?
Okay, so it is that diagonal from the fold corner
So
down.
I basically looked at, I folded it this way.
Because it's rectangular, it's not corner, it's not a... My problem was, okay, so I have in half, and then I have this. This is my folded edge, this is my folded edges. And it's this point that you're cutting off, correct?
You gotta cut from the center, you know that?
It's the one that's all folded together. It's the middle one.
Right, but I'm looking for where you cut.
And there's, where they all meet, where all the folds meet.
Yeah, but I don't see, like you're holding it below the camera.
Oh, okay, sorry. So I had this,
Right.
and then I folded it, like that.
Yeah.
And then I cut like a V shape in the corner. I folded it, then I cut the V shape.
So it was 2 cuts?
No, just 2 cuts.
Yeah.
Okay.
I think she had
I think
2
if you fold it again,
Yeah, I thought you did.
you can make 1 cut.
Because I wanted to have okay.
Yeah, I definitely have to go get more paper. Okay, let's see if this... See, before I cut the wrong... but I didn't get a 5-pointed star. I got an 8.
You got 6, Ingrid, though.
Yeah, 6, so that's not right either.
I'm confused about what we're doing. If someone wants to tell me, I just this paper.
I got 3 here, and this one and this one. sheet. I can go get my book that has it, but I don't want to. But I'm out of paper. I'm actually going to have to go grab a stack from the room we used to.
Okay, so is that we're getting
I'll be right back.
5 stars, some many stars? Is that a 7 I think? It has a 6, is that correct?
6.
Yeah.
6.
Calvin got the 5-pointed star.
Yeah, Calvin got it.
I'm not really sure what I did, but I did do it.
Awesome. So after you got it, the next thing to think about is how to make it reproducible for yourself, and then how to explain it to yourself so that you can explain it to other people. How is it that this knowledge is
That's cute, Sue.
Yeah, that's good,
Oh, I
Sue.
like that.
I have no idea what we're doing. I got no clue, guys.
You're muted, so I can't hear anything.
Supposed to be folded a certain way or what?
Back.
And folding origami.
What happens if you fold it the other way?
And then just yeah. Is there origami paper? Is there origami paper out there? No. No.
You split it in half, and then you make 4 folds around the center. Like
These are not.
1, 2, 3, 4. And then if you cut it, you'll get 5.
Hmm.
Can you get some
3 folds? Okay, if we do 3 folds.
If you do 4 folds,
Yeah, I did 4. This is when I got the 8-pointed thing.
Oh,
But it wasn't the goal.
for some reason, when I did 4, I got this one.
When I did 4, I got that one.
Well, here's a symmetric. You probably did like 1, 2,
I did
3 like
and
that.
then I folded it in half again because you said you cut a V, and I was trying to do it with just one diagonal cut. And I
Yes.
yeah.
So you don't want to fold it in half again because that'll just give you powers of 2. You have to fold it like this, like
So I did one
map.
fold here.
Yeah, you get 1 fold in half.
Again.
No.
And then I folded. Oh, here I got the wrong line. Thought I did a diagonal, but that's not it.
Yeah, you probably did. You can't fold it in half twice because that's not going to give you 5.
Right.
Donna, did you fold it hot dog and hamburger?
You found it?
Yeah, if you fold it just once in half, because you need to fold it 10 times, because you need to duplicate your cut 10 times for each side of the star.
Okay.
Okay.
So what you're doing is you're folding your paper into
It's
10.
cuts.
Oh.
Yeah, so you have to fold it like this, or you can fold it the other way, I guess, but it's probably better like this. And then you want your points to all meet like here. So you have to sort of fold it on the axis. So you have 1, 2, 3, and 4.
Oh.
And there's no way of doing this evenly. But if you cut across all of these, it should work.
Just one cut, right?
Yeah. And then you have, well, it's kind of irregular, but.
Wow.
There might be a better way of doing it that will make it actually, like, come out even. But at least it has 5 points.
Yeah. That's pretty good. Alright, I'm gonna use it.
Did you end up with something that looked like this before cutting?
One,
Yeah, it does look something like that.
I mean, I kind of made like a paper airplane.
2,
I folded it once, I folded it again, and then I folded back the edges. I folded it on a diagonal, the 3. This was 4, and then I did 5. I'm trying to debate where I'm going to be cutting. I think it's this part
Yeah.
that gives you,
what is that part?
because that's where all the folds are. No open edges. Let's see what happens.
Okay, go for it.
And if I remember, the steeper your angle, the more sharp your points or something.
You got 1, 2, and then fold.
Now,
Yeah, one more fold. So you'll get 6 if you just fold and fold.
Really?
that one didn't work.
Well, 3.
I need one more fold?
Yeah.
Okay.
Okay. You need to go.
Yeah, that's the tricky part because 5 isn't an even number.
I should have grabbed my books while I was getting paper.
And cut. Ready?
One, that's one fold.
Yeah, you get 1. And then what you do is you fold in, not all the way, like that. And then over again. And then over
Oh, 6 again.
again. And then over again.
I don't know why. I keep getting 6.
I think that's what I
Show it. After I
So it's kinda like that.
getting that look. Am I the only one who's really struggling with this?
I'm
So you
struggling.
start and you fold it in half,
Yeah.
and then you're taking it in, but you're not taking it down to the center. Because
Oh, you want to choose, so this is where it's folded, right? So where it joins, you fold inward.
from the folded edge.
Yeah.
The folded edge is on top.
Yeah, folded edge is on top.
So you're folding it just part way, like that.
Yeah, about like that. And then you fold it over again from that part.
Okay, so I have something that looks like this.
Yeah. Right, like that. And then again.
This is 2.
And then 3. And then 4.
What about the rest of this?
Oh, so you might not have made your folds big enough.
So you didn't need that part?
No, I mean you want each fold to be about 1/5 of your thing.
But when you're left, you have this triangular shape, and you have this piece out here.
No.
Okay.
So you want each fold to be about. So if this is 180 degree, you want each fold to be about 1/5 of that, right?
Okay, so that's 90. We're not folding it in half, but we're going to fold this piece down.
Yeah. And next piece over.
And then that again.
Catherine?
And
that again.
What about this side? We're not doing it here?
So it should cross over to the other side. Yeah, like that.
So now I want to do the same thing on this side?
No. So it's not going to be symmetric.
It's going to go like that.
Yeah.
So this.
And if you made it a little bit bigger, it would be, yeah. So I have a little bit leftover piece. You have a bigger leftover piece.
Okay.
You want to have not too much leftover. So you're going to cut this forward side.
This top piece that's all the folds?
Yeah, where it folds, you want to cut off that bit.
Okay. I can see this is not working.
Yeah, I think if you make slightly bigger folds, so this is not great either, because the folding is regular.
With the 3 on top, 1 weird one, and just a corner. I didn't cut in enough there.
Yeah, well, it's a basic idea.
Enough, I should say. Huh.
Yeah, that's a bit better.
What's the very first fold?
Wait, but Calvin, your stars are not all symmetrical, right?
No, I do not know. If someone can figure out how to make a symmetric 5-pointed star, I would be really impressed. This is all I've been able to do.
No, that's
Yeah,
good.
like this.
That's good enough for me.
Okay.
I should have done this in my kitchen.
Are you giving us maybe 2 more minutes to then come back together and talk about this process of the Okay? Yeah? Okay. And just 2 more minutes. Thank you.
Okay. So my folded end is here. think I'm going to end up with 6 points. And I have that weird bottom. Oh, well, now I have 3 and a flat bottom.
So that's close.
Well, at least this part looks good, right?
Yeah,
Yeah.
It's a sun
that's really
rising
good.
over-
That's all. They're all even.
Well, it's actually, isn't that actually 5? You just count the flat bottom as
Yeah,
2?
that's the problem. This part wasn't
Yeah.
put in.
Hi, everybody. So we're back. I was going to ask, all right, so let's start off by talking about in chat. Can you just type in and mention some of the things that you noticed from this exercise, trying to cut out a 5-pointed star with one straight complete cut? Folding into tenths is hard. I see. So when we're trying to make a 5-pointed star, we end up with 10 folds total radiating out from the center. So we need to make 5 total folds. Okay. How about mistakes that you made that were productive? Mistakes that taught you something about how this works. Okay, so seeing how the number of folds correlates to the number of stars is one thing. Making an even numbered number of points is another thing. Experimenting with the angle of the cut. Okay, so I promised that I was going to show you this in slow motion under a document camera. So here we go. Okay. Let me pull this up a bit. So if, it is way too zoomed in. There you go. Okay. So if I take another square sheet of paper and I fold it in half, so this is our first move. If we think about what's happening and we imagine that we've already cut out the star, what we've done is we folded the star in half. Like so. Okay. Our next move is to fold it like this. I usually line up this corner more or less with the edge, but the reality is that I'm actually just guesstimating. However, when we're folding if we look at what has happened, we're folding this part here. And what we're left with is a symmetrical object. This has bilateral symmetry. So if we fold this paper over here, and we fold it in half, then what we've done is we folded this star in half. Okay. This part is hopefully easier to figure out what to do because we know that we're going to have to cut here. We're making some kind of cut. So to get a side that we can cut out with just one straight cut, we can fold this in half again, and we get this shape. Okay. So then this is the basic shape. Then we have a question about what kind of angle we need to cut it at. This part is also easier if you're thinking about where the star already is. If I cut along here, then I'm going to get a steep, well, a sharper pointed star. Because this unit is replicated 10 times in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if it's pointy, then we're going to get a steep angle here. If it's not pointy, however, something else happens. So let's find out what happens if we make a non-pointy cut. Okay. Well, in that case, we get a blob. And the closer that we get to making a 90-degree angle, the closer that we'll get to making a pentagon. In this case, my angle was a little bit obtuse, I think. So then we didn't get these straight sets. Okay. So I want to take just a moment to see if there's anybody who needs to take any think time. Let's just take a moment to let it digest. And if there are any questions before we move on. Okay. I wish that you have several squares ready to go. To be honest with you, this is I'm actually going to write this down as our first question of investigation. If it's okay, I'm going to change your question to the following. So here's some questions. Question. Does the shape of the paper matter? I'd like to collect a few more questions about, I guess, so, okay, so to be specific, let's ask some questions about this. Okay. Can we produce any kind of polygon? Okay. Keep going. Let's brainstorm. Just try to get out as many questions as we can. Can you produce disconnected polygons with the same cut? Okay, and we make non-symmetrical shapes. Okay, more questions, maybe 2 or 3 more? Can you think of anything else you could put a knob on, or anything? Ooh, yeah, it should be recorded, I think. It is recorded. Okay, can we use the number of vertices of the shape to determine the number of folds needed? Okay. Is cutting the outer shape change what can be created? 3 random folds. What happens? Okay. Does symmetry affect how many shapes are needed on top of the number of vertices? Are we worried about paper being thick after too many folds and difficult to cut? Does it matter what order we fold in? Okay. I'm running out of paper, and these are all fantastic questions. I'm actually going to answer none of these right now, because I want to make sure that you have half an hour or so to explore your own questions. The kinds of questions that we've asked so far fall into a few categories. There are kind of, I would say, engineering questions. Well, there's questions about like process, where we're asking about like the presets of the problem. Does the shape of the paper matter? Does the order that we fold in matter? Does the fact that actual paper can only be folded a certain number of times and theoretical paper can be folded infinitely many times matter? Or I suppose, when does it start to matter? Then there's questions about outcomes. Specifically, we have questions about kinds of polygons. We have questions about whether the regions need to be connected. We have questions about symmetry. And then finally, we have one more class of questions, which I would call combinatorial questions. In other words, how does what we're doing have to do with the number of certain things? Can we quantify the symmetry and then turn it into a question about, quantify the symmetry, and then can we see something about the number of vertices? Can we relate the number of vertices of the polygon to the number of folds? Okay. One that I didn't see that I'm a little bit surprised not to see is the generalization. Could we do this with like a three-dimensional cube where we fold it somehow, and then we cut along a single flat plane? Nobody knows. So this is what I'd like you to do. Let's investigate these questions. Spend some time with the people at your groups and see what kinds of things you can make. Let's just try it. Let's try to be creative and think outside the box. Okay, thank you.
I don't even know what group we are.
Hello, I don't know what group we are either. We're 401, I think.
Hi, can you hear me?
Yeah, I can hear you. Can you hear me?
I hear you, Calvin.
Ren.
I can hear you.
The sound's going to come back. Yeah. Calvin, the sound is kind of loud from you and a bit distorted. Is there any change you can make on your end, maybe, not to be so loud?
It's
I mean, now you're weird. Can you hear? You can hear me, but yeah, Donna, I can hear you fine. You're a bit. Weird. I'm getting like bubbles. So Donna, I can
hear like tapping in the background. Like,
yeah, I hear that too. I don't know where it's from. Yeah, I can hear you fine, but a bit faint. But it's fine. It's not disturbing in any way. But for Kelvin, it was distortion. Were you hearing very loud and distorted as well?
Yes, Calvin. There was almost an echo.
Yeah.
But sometimes I have one person I can't hear at all.
So
I raised my volume. Is that better for you?
Yeah, it's good. Oh, if you turn it too loud, I'm going to hear myself in your speakers.
So what are we trying to do? Because I didn't even get the star. I couldn't do the folds for that.
We're trying to explore some
of the questions. I didn't get it either. I was too busy trying to get the paper set because she switched from a rectangle.
Well, I didn't even get how to fold it right for the star, so I'm not going to be much help.
The questions that were raised, I don't think.
I feel like I wanted to know.
So, Donna, I don't know if you remember, but were you present for any of Sunita's sessions in our MTC? Because we did this topic actually. Were you not present for that session, Donna?
All right. I lost your audio, Julia. Which one? I lost your audio. I didn't hear you. Are you hearing me?
Yeah, Donna, I can hear you now. Yeah, you froze for a little bit.
Yeah, people are cutting out. I'm going to have to refresh. They told us to refresh when we lose people.
Yeah.
Am I any better now?
It's still the same for Calvin.
Oh, yeah, that's just going to be how it's going to be. I'm afraid it's my hardware.
Okay. Yeah, I'm not sure why. Yeah, anyway, so any questions from what she raised that you guys want to explore?
I don't even have the questions in front of me anymore.
Well, the first one was, does the shape of the matter of the paper matter, the one you start with? So,
Well, I guess it really doesn't, because you can fold a piece of paper partially. So I know she had a square and I had a rectangle. I was trying to figure out her folds. So I wanted to start with the square, because before she said, oh, you don't need square paper. So I didn't grab any. But right away, I needed to at least try for that one to match what she was doing. And that took time. And then I missed the first two folds.
I never got it right.
Yeah, I missed the first two folds. I heard her say fold it in half.
yeah, the first was this one. So just that.
Just
right?
what they call a book fold.
Yeah. And then I believe she did something like this, like you take a corner and you bring it to the other, yeah.
But is it the corner from the folded edge or the open edge?
I bring it down.
It was from the folded edge.
And she just brought it down to meet the opposite side.
Yeah. So kind
And
of
she
like
didn't
that.
specify.
I think that's where it makes a difference.
Well, mine doesn't look like yours already. Oh, I don't know.
Right.
Because it's a different distance to the other end with a rectangle.
So that.
Who's
See,
speaking?
that's what I didn't do. I don't have the second fold. There's the first fold. Now what?
And now you take the.
Okay.
Yeah. One corner
And it's
from
past-
the folded edge.
And
you
it's
bring it-
past the midpoint. It's past the midpoint.
So I have to fold this here to get to the midpoint. Okay, so
Okay,
that's
but
my
when I do
midpoint.
that,
So fold it. See, I still don't have it. It folds like in half. How are you getting?
Yeah, that's very different with a rectangle than with a square.
what you have to do,
Are you
Sue.
unfolding your paper or not?
No. But Sue, look. What you're doing is you're folding it to
Wait,
meet
did
the
I fold it the
opposite
wrong
edge.
way? Okay, yeah.
Now, but look, this can go anywhere along this edge. You see how my piece is hanging below Juliana's? I slid it back more. You can slide it back. It's not past the midpoint. It's still, if you picture this folded in half again with a vertical line here,
Okay.
this is not going to go that far. It's going to stay closer to the corner. What happens is you can move this point anywhere on here, on the edge. But if you move it too far over, you end up with a piece hanging down below the
So
edge
it's like
of the
this?
paper.
Is that right then? Folded like, can you guys see? My lighting's kind of bad.
Kind of, yeah, that's okay.
Yeah, because it's not an exact science.
Okay.
It's just somewhere along that bottom edge, but
All
not
right, then
very
what?
far.
Yeah, what was next? I'm trying to remember.
That was the problem. She was moving fast, and the document camera was very jerky, so it wasn't a smooth fold. It was like you suddenly saw a finished object. And I
Yeah.
have a feeling that it was something where this gets folded over also.
Oh, I think it was this one. Yeah, this part goes over that corner, right? Over
Right
that over
up
this
to-
line.
Right along the edge of the first fold.
Yes.
So here you
Let's try that.
Right, so you have this fold. I just didn't do it right myself.
Okay.
And then
And then what?
I'm
now
confused.
this is just going to fold right up to that piece, I think. And then I don't know if it was a continue to fold it like a wrap or to fold it back on itself, but we're starting to get that shape.
She did something with the symmetry of it.
If it makes you feel like
We have one fold.
speaking, is that Sue?
No, Calvin has
Oh,
the.
Calvin, I'm sorry. I didn't see your mouth moving, so I didn't know who was talking. What I'm trying to figure out, well, I just figured, is Sue, this is a very standard origami thing, so you could look up 5-pointed star in origami and download instructions at any point. there's a lot out there online. It's a very standard fold. I just couldn't remember it. I used to do it with my
I
students.
don't know it.
So I know this. I'm guessing at this one. And I know you either, I don't know if you fold this back on itself or you keep wrapping it. Because she worked with a square. And this is started as a square. You see,
then
if
where
you
do you
wrap
cut
this
it?
around again. I mean, you could keep wrapping it until it's just
And where do you cut it?
phone.
All right. I Googled. Here's the YouTube video.
Or down here? Where do you cut? Up here?
Well, okay. First fold was in half. Second fold was down to the point. We did a third fold by folding it over. Question is, what do we do next?
Can I share the screen a little bit? I think I found the
That would
video
be-
for it.
Do it.
Let's see if that works. All right. Let's see if this is what she did. There we go. Do you see this?
Yeah.
So they're starting on the long way.
But you opened another screen here.
Oh, and I folded it the short way. Okay. Oh, they unfolded it.
Oh, so that was just to get the middle point. Okay, now they're getting to the midpoint.
Okay.
Now you lift that. Oh, okay. That's the one we forgot. And you get to the edge.
Okay, so that one used a midpoint.
Okay. And now that goes over that. Okay. And finally, that goes over that. All right.
I'm still not sure if I did it right.
Did you follow?
No, I'm having trouble seeing it. It's so small.
Oh, let me
Click
see.
on the top right and it'll enlarge.
Is this bigger?
No, I'm on an iPad, so
Well,
okay, that's a
continue it.
little better, yeah.
All right. And next,
And I-
probably you're going
No,
to
I
cut
can't
the
redo
longer.
it. I don't know what Calvin's doing. He turned his mic off.
So what are they showing to cut?
You wanted to complain about my mic, so I turned it off.
Right.
Okay. It sort of looks like a necktie, you know, when you finish folding it.
All right, they're
It has
cutting.
that necktie sort of look to it.
Did you see where they cut?
Okay. I need to see that from the beginning again.
Yeah, I got this. I got half a star. They must have kept the fold.
Yeah, so you didn't do the last.
That's what I had at one point. 3
I didn't keep
points
the fold.
and a flat
apparently.
horizon and a flat edge like a horizon.
So let me post the video in the chat and then you can watch it on your computer and you're going to see better.
Look, I got a star from what you were showing me, Juliana.
Yeah. There we go.
It's not quite even.
Yeah, you did.
It's a star.
All right, I posted the link in the chat. So if you click on it and open it in your own tab on your computer, you can watch it
I
later.
think it's if you just end up with that right shape at the end.
And Calvin, you have it, right? You got it to be good or no?
I've done it. I haven't managed to follow either what the leader was doing or what the YouTube video was doing it, but I have made 5-pointed stars.
Well,
Yeah,
why don't
I've
you
done it
show us?
before.
Why don't you show
I
us your
just-
codes?
I think I need to turn
Show it.
around to light because I was sitting by the window.
So we should talk a bit about those questions because that's actually what she wants us to do. In like 5 minutes, she's going to bring us
Yeah,
back.
that's true. That's true.
I feel like I've been
And
sitting
you're
in
not
the
showing
shadow.
your paper good enough to follow.
So I guess on the matter of does the original shape of the paper matter, we saw that it could be square or rectangle and probably maybe it can be
Not in the
something else.
best version of
Although
this, so
Well, the point where it makes a difference is any point where you're folding something over to the end like this, right? So if you're folding it over to the edge, it matters where the edge is, and that's going to be different if you have a rectangle.
Yeah, and I did it with the rectangle and
Yeah.
fine as well.
I would think, yeah. So I think.
But if it's, let's say, a trapezoid, and you're folding,
If
it needs to be something with some kind of symmetry, right?
All right, counting the folds.
Well, I think as long as you're doing your cuts in the center, from the center, as long as you have some center area that's all right, kind of doesn't matter what's going on the edge as long as there's enough space.
Mm-hmm. Yeah, so the only place where that outside edge mattered was that thing where one corner was going through that edge, right?
This part's
but if you're just eyeballing it in a different way, it might be okay.
Yeah.
Yeah, well, you wouldn't fold it in half. I mean, if you're not able to fold it in half easily, that would be hard.
Yeah, you can see I'm starting to get like the point here and here, but not down here. So when I open it, I have 3 nice ones on top again, and then this weird shape down here. But that's part of the paper I thought was excess. I wasn't able to get that into a star shape.
Mm-hmm.
Huh.
If you, Donna, did you click on the link I sent? You can check that later.
It wasn't in the
get
center,
it.
so I ended up with. Okay. So again, if you start with a rectangle, fold the long way. That's a midpoint. Fold that part down, try it that way at the midpoint. So I just started with a small scrap now. And I folded it the long way, found the midpoint of it, and then used the top of the next fold at the midpoint and folded it down. And now it extends below the bottom edge.
But that's not what they were doing. They did that first fold that way, then they opened that fold.
That makes sense so far?
And
the question is to fold it over again.
So while Donna's trying that, anybody wants to talk about any of the other questions?
1,
We're still trying
2,
to do
3, 4 folds, and we said it was 5 folds. And then if I fold this back, maybe this is just excess because it was a rectangle. What happens if this gets cut off? That's not going to do it. I can see it's not going to do it.
Donna, you can check out that video later that I posted in the chat.
Okay. Well, I mean, we can't even get the first parts of the video, so I don't know about the rest of the questions.
So this is what I got from the video. So it does work.
Disappeared. The Sue disappeared.
It does seem to be a very different set of folds, though.
Yeah, well, we're still struggling because when you did it with the document camera, my stream was so jerky that I couldn't see smooth folds. I kept seeing shots of different things, but I couldn't see how you got them.
I'm sorry about that. It's really hard to tell from my end that that's happening.
No, it's really, I think it's because I'm on an iPad using Safari because Chrome didn't work when I tried to get in yesterday. So I was able to only do it through Safari. But, I mean, this is an easy thing to look up online, so I know that. But because we were just saying, and I started here with a strip of paper, rectangle, folded it in half the long way, and from the fold found the center, and then folded that piece from there down, and then folded it over again, sort of getting the shape. Not sure what to do with this piece. I didn't know if this keeps folding.
So if you undo your last fold,
right?
Yeah, and then if you fold, okay, there, stop. If you take the rectangle extra and you fold the top part of that to line up, with the not quite.
Not
okay, so you have this. Fold this part to line up over here.
To line up with this edge?
That's right.
Like this.
I think, yes, exactly. And then you see that top angle that you've got? So this is the part that you just folded. You just folded this to here. So then you get something like that. Then fold that in half.
Right.
That's right.
Just fold that. Just fold that in half. It doesn't matter where the edges come out. I see. Okay.
Right. And then if you look, okay, I think it's your right hand. So if you take the scissors, you're going to cut starting from where your right hand is.
My right?
Okay, so it looks like your scissors are in your left and the paper's in your right. Is that right?
Right. Yes.
Okay. So if you
this way?
Right. If you start on the side that you're holding, exactly the opposite way, like mirror image, yes, that's right. That's right. Okay, cut.
I think the problem is being a lefty.
Well, I learned something today about how to do this.
Okay, almost. This was that like extra piece of paper that, I didn't know what to kind of. So actually, if this got, I don't know, trimmed off but that's a fold line, so I can't. But somehow this part,
right,
this piece here somehow.
You can also cut it at an angle so that part ends up getting cut off.
Right. It should have been more like that, almost. I bet that will help it. Maybe not. I used to be so good at visualizing.
It's a lot harder over the internet.
Yeah, it is. I once found a problem in a geometry, closer.
Woo-hoo. Look at that.
A lot closer. It was once a problem, an enrichment problem in a geometry text, a high school book. And it told the kids to fold a piece of paper, square paper, in half, or actually rectangle, it didn't matter, in half and in half again, and with a hole punch. They had to make one hole punch a little bit in from a corner, from the folded corner. And before they opened it, they had to describe what the pattern of holes would be.
Oh.
I had never thought of doing that. That is one of the most interesting things. Those kids got so involved in trying to visualize where are the holes going to come out when it's open. And what if you make 2 holes? They came up with, what if we make 2? And what if one of them is actually right on the corner, half on the corner, and a couple of them inside? And they had a blast. And I think they learned more geometry that day than they did the entire year. They were so engaged. And that was a wonderful textbook by Key Curriculum Press, and I think it was called, and that was one of their enrichment problems. So simple, but I had to make sure every kid had a hole punch, to share. So I had to go out and buy a bunch because the schools had no supplies. But I thought that was kind of like this problem, make one cut.
Yeah.
I did a Japanese lesson study. They had us build a cube. And after it was all taped together, because you mentioned a 3D cube, we had to figure out what would be the minimum. I'm trying to remember, one cut. You had to cut one edge. And before you opened it, you had to describe what that was going to do, just in order to refold it. I can't remember the problem. I have to look at my lesson study notes in my file cabinet. But that was also a good one, because you had to know, you had to think about where you wanted to cut, which edge you wanted to cut open, to lay it out. I think to lay it out into the right template, to fold a cube, to make a template. It was interesting.
It's pretty massive.
So that's kind of thing that's kind of thing I like to do, and that's what this is. So so now I sort of have the idea of what to do with that paper. So now to your questions, which we haven't really gotten to address yet.
Well,
I mean, Juliana, you asked about making other polygons, right?
We did talk about the shape of the original paper, right? We said that doesn't matter that much.
Right, because you may have to leave some paper might have to actually be cut off, though, because it folds perfectly with a square, but with the rectangle, I didn't have it exactly right.
You can cut off stuff anyway. With any of them, you can cut at an angle. There's no unique cut. She was saying, right? If you want to make sharper angles or
right, it gives you sharper points, but you have to know. Like she said, I could have adjusted where I cut to cut off that excess. So with a square, it doesn't seem to matter, but with a rectangle, there's going to be extra paper that you have to adjust your cut to get rid of it, to get a nice shaped star. I mean, it depends on the shape. It depends how perfect you want it to look.
Yeah.
I think the rectangle is less perfect.
Yeah. So let's talk intuition a little bit. What does your intuition say? Can you get any polygon whatsoever? Doesn't matter how many sides, doesn't matter what kind of symmetries or lack of symmetries. Can you get it through this process to cut it out like that?
With one cut?
One cut, same rules.
I think you might have problems with odd total number of edges. Although if you did it exactly right and managed to get the pentagon like she did with the straight right angled cut, that might be a real way around it.
Yeah. The number of folds seems to determine the number of vertices. The angle will give you whether it's going to be convex or concave. The more straight, the more you're going to get a convex look. Right? The more we cut in sharper, you got a much more stellated polygon. Does that make sense?
Yeah, I'm trying to figure out if I understand what you mean.
Well, she said, we did 10 folds to get 5 points, because each point was now folded in half. On the 5th fold, you really have like it's almost like making 10. Each point had a fold in the middle.
Mm-hmm. But you don't need to do 10 folds, right? We did
no, it was 5 folds.
Yeah.
But in theory, it was like getting 10 points, but 2 of them are attached.
Mm-hmm.
Because that's the fold of each point. So it was the angle has been cut in half by that fold line for each point.
Did we lose somebody?
Yeah, Calvin went off. And he's having trouble with his microphone.
Yeah.
He said. And Sue disappeared.
Is Sue still there?
Yeah, for some reason it turned you off for a while.
Sometimes they told us yesterday that if you have a problem, like somebody you suddenly don't hear, but their mic is on, to refresh the page. So I had to do that before. We looked at your video, and it still went a little bit fast for us because I hadn't enlarged it, and seeing it this big was a little tough to tell what they were doing in the folding. But I think we got a little closer.
I put it in the chat, so just click on it, open it in your own tab, and then you're gonna.
Oh, that'll be good.
Yeah.
I guess they're going to be. Is that what? There's one message in chat.
Yeah, it might be that one. Let's see in the general chat what are.
Yes, it says table chat, table 3. I guess we're table 3.
Yeah.
Yeah, that's the YouTube for the star.
Mm-hmm.
Okay, that's good to know.
So nobody's typing anything in the general chat. In other sessions I was in, there were all kind of messages from other tables, but put in the general.
Right. But the other thing is, the first one that I attended, I was emailed the general chat. But,
okay.
Yeah, I was having a lot of issues because they were trying to get me in on Chrome and in Safari. But then I haven't gotten it since then, so I don't know if they're emailing these to us.
Yeah, I don't know.
Or we have to go seek it out here.
Emailing.
I think they're going to wrap it up.
We're leaving the table. They're taking us out 26 seconds. At least that's I have a message.
So what intuition-wise?
So I guess we'll go back to that.
So intuition-wise, what do you say? Yes or no? Can you cut any polygon through this process?
I've been trying to do a triangle. I'm not sure you can do it.
Hi, everybody. Welcome back. I called you back in because we have only about 7 more minutes, and I wanted to talk a little bit about the mathematics and history behind this problem or this series of problems, and to give you some resources for exploring it potentially more on your own or with your students. So, okay. So the way that I came across this problem was through the work of a mathematician named Eric Demain, who is at MIT right now, because it was featured in a couple of documentaries from, I think, Nova. One is called Between the Folds, and the other one is called The Origami Revolution. And what they said is actually the answer to this question, which has been arrived at, is that given a theoretical piece of paper, meaning as thin as you want, and you can fold it as many times as you want without tearing and all of that stuff, you can actually make any region in the plane that you want with one single straight complete cut. You can make every letter of the alphabet. You could make, if you made your cut have a tiny bit of width, you could cut out the New York subway system. You could cut out anything, not curves, although you can approximate them. So if you take a circle and instead have a ton of very, very, very small line segments, so that you have like let's say a polygon with 100 sides instead of a circle, then you can make something very, very circle-like. To the point where, because we're working with physical materials, it might as well be a circle. And it's useful. Yeah, Alana. Actually, I'm going to drop this link right now. One of the resources that I wanted to give you is his webpage with examples of fold and cut. One of the examples that he has a swan, he has an angelfish, he has a butterfly. And these are all things that can be made with one straight complete cut. The first time that I tried to make a swan by myself, though, I was just kind of guessing, and I ended up first with a bunch of connected stars, which was a nice surprise, but a very unusual mistake. And then I ended up with I think, was it? Oh yeah, and then eventually I ended up with something that looked kind of like a duck. But if you follow his instructions, then you'll get an actual swan. Now, Yes, you can cut the letter A and the letter H as two separate regions with the same one cut. If you see his example, for example, he also has it so that you can make one straight complete cut and get the words MIT. Although when I saw him do this on a video, you have to use a box cutter because the paper gets kind of thick. Now, another question might be sort of, what is this about? Aside from a really nice geometry explanation problem, it turns out that this has a relationship to angle bisectors. Because if I take a scalene triangle and I imagine cutting this out, then what has to happen is it has to get folded so that all of these are on one line. When that happens, I'm going to be folding so that this line goes onto that line. So this has to be the angle bisector. I have to make this line fold onto that line. So one of the folds has to be the angle bisector for that pair, for that angle. And then finally, I need to fold this line onto this line. So we need to make another angle bisector. But then if we imagine folding this, okay, I'm just going to do it. If we imagine folding this, then we end up in trouble. Why do we end up in trouble? Well, look, we've got kind of a tripod. This isn't folding flat. It doesn't work unless you do something like constructing a perpendicular bisector here. You construct an altitude so that then this will fold onto itself. And now, if we cut here, then we can get out our triangle. Well, I did a lousy job of folding it. So it's a little bit, you can see there's this little bit of excess here. You have to be more precise and maybe use a ruler when you draw your triangle. But this concept will fix the problem. And you may note that we only needed one more perpendicular to get what we wanted. To do this for any shape that you want, you're going to have to be careful about where you put your perpendiculars. And you can think also about how many you need, whether there's a possibility that in a bad case, your entire paper just becomes one huge mass of infinitely many folds. And this can happen, although it happens with basically zero probability. And there's lots of other kind of interesting considerations. But when I taught this in a high school class, what I taught it as was as part of the the special lines and triangles unit, because it's another way to think about what the angle bisector theorem actually is telling us. It's telling us something about a fold line. So I'm going to add a couple more resources. If anybody else has any questions, though, please feel free to ask. Here is a number file on fold and cut. Here is Eric Demain's MIT lecture. On fold and cut. Oop. Oh yeah. And before we conclude, one more note that I wanted to add. I forgot this most important thing. The history of this problem actually starts. So Eric Demain picked up this problem because he was interested in it based on a Martin Gardner puzzle book. Martin Gardner, in his article, writes about a couple of other sources of where this problem comes from. The star problem was first published by Harry Houdini as kind of like a magic tricks you can do at home puzzle. And there's also a story that being able to do this, making this star, was how Betsy Ross got the job from George Washington of making the American flag. But even before that, if you look at this paper, there's also a Japanese puzzle book from the year the late 1700s, where one person challenges another person to cut out their family crest with one straight complete cut. The crest looks a lot like this. It is an overlap of two rhombuses. And then, of course, they go on to explain how it's done. I didn't know that fold and cut is used so universally. I had never heard this about China and Mexico, and I'm really excited to learn more because this is one of my favorite problems. So that is it for today. Thank you so much, everybody, for participating and for thinking and for sharing your questions. And I hope that you have a wonderful rest of the conference. Thank you very much. Have a good night. Bye.